Starting chapter 3 today, lesson 3.1 talks about fractions and decimals. Mainly, the lesson is in reference to taking a fraction and converting it to a decimal. So I will show you how to do that when it's not something very common, but right now, that list on the left-hand side, those are fractions that I feel like you should just know automatically the decimal equivalent. And I think you'll agree with most of them. There might be a couple that you're not sure of, but I'm going to say that they're very common, so you probably should just know what they are. So starting with 1/2, or the top, what is the decimal equivalent to 1/2? We're just going to say, well, if I can get it to right. Hang on, let me put my wrist guard up there. 0.5. Okay, what about 1/4? Jessica? 0.25. What about 3/4? Tori? 0.75. Okay, 1/10. Shane? 0.1. What about 1/5? 0.2. And what about 2/5? That'd be double that. So what would that be? Somebody that has an answer. Stephen?
0.4.
0.4. And then what about 3/5? Somebody that has an answer. 0.6. Okay. Have we surprised anybody yet on any of these?
No.
Did you already know all these?
I did this like last week.
Good. Okay, so let me kind of pull this down a little bit so we can continue our list, and then I'll have to go back, I'm guessing. Okay, so we just finished 3/5, so we're ready for 4/5. What's 4/5 equivalent to? If you kind of follow that pattern, somebody that hasn't answered yet, what's 4/5? Drayton? 0.8. All right, what about 1/3? What do you think about 1/3? Somebody that hasn't answered. Do we know about 1/3? Okay, what's 1/3?
0.33.
Okay, I'm going to say 0.3 repeating. That's a repeating bar. You can see it right over here talking about a repeating bar. It's called repeatend. I don't know. It's something that you repeat continually, then you put the repeating bar over it. So if 1/3 is 0.3 repeating, what would 2/3 be then? Somebody that hasn't answered. If 1/3 is 0.3 repeating, Haley, what's 2/3?
Is it 0.6 repeating?
It is 0.6 repeating. Okay, 5/6. That one you may not know. It's in my list. That one you may not know. Does anybody know it right off the top of your head? Okay, so this is a good as time as any to show you how to find a decimal equivalent to a fraction if you don't know it. That bar right in between the 5 and 6 is a division bar. And it means 5 divided by 6. So that's what we're going to do. We're going to take 5 divided by 6. Now, obviously, 6 doesn't go into 5, does it?
No.
Or else it wouldn't have been a fraction. So at this point, you add a decimal right there, and you add a decimal right up at the top, and you add a 0. Now, how many times does 6 go into 50? How many times does 6 go into 50, Braxton?
8 times.
8 times. And what is 8 times 6, Braxton?
48.
48. So when I go to subtract that, I've got a leftover. So I'm going to add a 0. And what you're going to do on these today is you're going to keep dividing until it stops or until it repeats the same digits over and over. So, Braxton, how many times does 6 go into 20?
3 times.
3, which is what?
18.
18. So when I subtract, I have 2 left over. So you add a 0 and you bring that down. So what now?
18 again, like 3.
It's going to be another 3. It's going to be 18, and it's going to go on forever like that, isn't it? So for 5/6, it's 0.83 with the repeating bar over the 3 only. 0.83 with the repeating bar over the 3 only. All right, questions about that? So that list is pretty clear cut. Maybe the 5/6 is the problem, but other than that, you should know those all just right off the top of your head. They're very common fractions. All right, let's go to this is the kind of thing that you're going to be doing today in your homework, right? As a decimal. Well, when you get one like 1/2, honestly, you're just going to write 0.5. There's no work that you need to show. You know what it is. In fact, if it's any of them in your list, I expect you to write the answer right down. But then you get to these 1/16. That's a problem. I don't know 1/16. You know 1/16 right off the top of your head? So with 1/16, you got to be really careful. You're going to take 1 divided by 16. And I want you to be very careful about your spacing, about your lines, your columns. I'm going to add a decimal right here after the 1 and then take it straight up. Well, when I add a 0, I'm trying to take 16 into 10. Does 16 go into 10? No, not at all. So you've got to have a 0 up above that line, the division bar. So 0.0, because that's what it is. Now, when you go to add another 0, now we're talking 100. So now we can do this. 16 goes into 100. Well, we got to think a little bit. Anybody know? It's 6, because 16 times 6 is 96. And 100 minus 96 gives me 4 left. Well, I've got a leftover and I don't have a stopping and I don't have a repeating, so I add another 0 and bring it down. Now 16 into 40. Well, how many times does 16 go into 40? Anybody know that? Just a couple. 2. So that's 32. And 40 minus 32 is 8. I'm still not done, so you keep adding zeros until it stops or it repeats. Now, 16 into 80, I think we're good, because 5 times 16 is exactly 80. That's great. I've got a remainder of 0, so now I know I'm done. 1/16 is equivalent to 0.0625. So you would have to divide that out and get that. So on all of these, you divide until it stops or until it repeats. All right, the next one is 6/11. So we're going to do that out here in the middle. We're going to take 6 divided by 11. Again, 11 doesn't go into 6, so we add a decimal and a 0. 11 goes into 60, Sienna, 5 times, and that is how much? 55. 5 left, we add a 0, and now, Sienna, 11 into 50. 4 times, okay, which is how much? 44. When I subtract, I get a 6, add a 0, and bring that down. Now, 11 into 60. Yeah. 5. Uh-oh. That's 55 because we just did it, and 5's left over. Now what? Now what do we do? Keep going? It's just going to be the same. So what answer would you give for 6/11, do you think? Do you know? .54. Repeating. Okay, now I need you guys to look at this right down here. This question. This is why this question's on here. It says, what's the difference? 0.54 repeating and 0.545 repeating. I was hoping that Sienna didn't say 0.545 repeating, because see, you really need to go beyond where the repeating starts to realize it's repeating, don't you? Yeah. And a lot of kids, I'm telling you, they make this mistake. They divide to right there, and they're like, oh, it's going to repeat. So when they go to write it down, they write down 0.545 and put the repeating bar, just like it says down here where we're asking what's the difference. Can anybody tell me what the difference is? What's the difference between 0.54 repeating, which is what the real answer is, and 0.545 repeating? Tori.
0.545 would be 0.5455455.
It'd throw an extra 5 in every time, wouldn't it? Yeah, this one would be 0.545545, and that's not what it is. That would not be equivalent to what we've got up there. The 0.54 is it. So I guess what I want to get to with this is you only write the actual digits that repeat and put the bar over that. Don't do another set. Don't try to get fancy and do something else. Just put the actual digits that repeat, and then that's it. Are there any questions about that, just so that you know the difference between those two? Okay, so let's look and see what else we have down here. Two more problems. This first one says less than, greater than, or equal to negative 13/20 compared to negative 7/10. So what you're going to have to do is put them all in terms of decimals to compare. So 13/20 you would have to change just like this. And 20 goes into 136 times, with 10 left over. When you add that 0, it's 5, which is exactly 100. So negative 0.65 compared to negative 0.7. Now, be careful. It's on the negative side. Remember what happens on the negative side? It goes in reverse. So what do you think? Negative 0.65. Is it less than, greater than, or equal to negative 0.7? Braxton, what do you think?
It's less than.
It is not. It is in reverse. Remember, on a number line, there's 0, there's negative 1, there's negative 2. You see how they go in reverse? So negative 0.65 is actually greater than. It's closer to 0 than negative 0.7. They go in reverse. So you got to be careful on the negative side. They go in reverse. Last but not least, we got to order from least to greatest. Negative 1.1, negative 1, 1/8, I'm trying, yeah, hold on, I lied, yeah. It's negative 1 and 1/8 and negative 1 and 1/10. So, yeah, there would be commas in between them. So, what is 1/8?
0.125.
It is. So, this is, we're comparing negative 1.1, negative 1.125, and what about negative 1 and 1/10? It would be negative 1 point what? 1. Okay, now be careful. This is in reverse because of negatives. So, can we do that? Oh, you know what? I see something there. That's got a repeating bar over it. Negative 1.1 repeating, so that means the first one is actually negative 1.111 and so on. Okay, so what is the smallest of those? Which one's the farthest away from 0? Logan.
1.1, negative 1.125.
Yes. So what I'm going to do, since it's this one, you got to write what was in the actual list. So I'm going to say negative 1 and 1/8. Okay, so that one's out of there, and that one's out of there. Which one's the next smallest?
Negative 1.1.
This one has a 0 in it, and this one has a 1. So which one would be farther away from 0?
Oh, look. Repeating.
The repeating one. So negative 1.1 repeating. And then finally, negative 1 and 1/10. That's because it's on the negative side. You got to be careful about that. That goes in reverse. Are there any questions? Uh-oh.